Friday go?
Struggle.
So I left you guys. I left you guys a video lesson to watch, right? It's like 20 minutes ish, and then asked you to work on a delta math.
Wait, there was no.
No, she didn't.
She didn't say it. She said
She said there was a video. She didn't ever do a job.
Okay, well, it was also on the agenda for the day on the My Notre Dame. All right. All right, so this will be a little bit more than time than I had planned, but that's fine. All right, so looking at our 3-1 notes, this is what you guys would have seen on Friday if you watched the video and worked on the delta math. So what we're going to be talking about in chapter 3 are the graphs for sine and cosine. What we'll start with here is talking about identifying the key features from those graphs. So there's 3 key features that we're going to be concerned with here initially. Those 3 key features are the midline. So the midline is a horizontal line that divides the graph in half. So like this red line right here is the midline. When I say in half, I mean there's like an equal amount of the graph above and below that midline. You guys kind of see that? All our graphs of sine and cosine are like these wavy graphs. We call that shape of graph a sinusoid. So the midline, like 50% of your sinusoid should lie above it and 50% should lie below it. The next attribute we want to talk about is the amplitude. That's just basically the distance from the midline to any extrema, so a maximum or minimum. So like this distance right here is an amplitude, or this distance down here is an amplitude, or this distance here would be an amplitude. Everybody feels okay there? And then the third piece is the period. So you notice how this graph just kind of goes up and down, up and down, up and down, and repeats itself over and over and over again. So if I look at one cycle of that graph, so like we did an up, and we do a down, and we return back to the midline, that's one cycle of our graph. The horizontal distance that one cycle covers is called the period. So the period's a horizontal distance that's covered by one cycle. Everybody's okay with that? So the first thing we want to do is practice just, can I look at a graph and identify the midline, the amplitude, and the period? Come up with the number. So if I'm looking at this amplitude here, we started at y equals 0, and we went up to y equals 1. So the amplitude here is 1. If I look at this midline's a horizontal line that goes through the y coordinate 0. So this midline is y equals 0. And if I look at the period, we started at the x coordinate 0, and we ended at the x coordinate 2 pi. So the period would be 2 pi, right? The distance from 0 to 2 pi is just 2 pi. Does everybody feel okay on that? Okay. Now, our graphs for sine and cosine can look different. They can be like transformations. So like, let's take a look at this one. If I look here, the midline appears to be at y equals 1. The amplitude, well, we start at 0, and it goes up, or I'm sorry, we start at y equals 1, and we go up to y equals 4. So the amplitude there was 3. Is everybody okay with that? Just kind of counting. And if we look at the period, I chose to start counting my period where x is 0. It just often just makes the counting easier. So I start here at 0, and I end here at pi. So the distance from 0 to pi is just pi. So there's my amplitude and my period and my midline. So far, so good. Let's do it for another one. So if I look at this guy, first thing I do is I look for that midline, just using my eyeballs. Again, I'm not doing anything fancy here, just kind of looking at the picture, right? So there's my midline. That happens at y equals 1. I look at my amplitude. I start at y equals 1, and I went up to y equals 3. So that amplitude is 2. And then for my period, I start here at 0, and I ended over here at 4 pi. So that period is 4 pi. Does that sound okay? Pretty straightforward, right? We're not doing anything other than looking at a picture and kind of reading what we see. Yes? Sure. Okay. What I want to do now is I want to relate these key features back to the equation for a function. Okay, so our sine cosine equation, I want to relate how I can look at that equation, figure out the key features, and then also how can I look at the equation, or how can I look at the graph with the key features and use that to build back an equation. So far, so good? Okay. So, if I look here, for us right now, we care about this, which is the general form for any sine or cosine equation, right? So I have one of these for sine, and then I have another one for cosine. So those coefficients, the a, c, h, and k in the equation, are going to tell me things about these key attributes. So if I look, the amplitude, I can find it's just the absolute value of a. The midline is just y equals k. The period is 2 pi times the absolute value of c. Those are equations that you'll use throughout the entire Delta Math assignment if you haven't done that yet, and going through into the homework today. So those are ones that you definitely want to have written down into your notes. We'll use them over and over again. They'll be good friends of yours by the end of the chapter. All right. So if I wanted to then do an example here where we'll start with an equation and we'll go through and figure out the amplitude, the period, and the midline based on the equation. So the first thing I want to do is I want to write down my values for a, c, h, and k. So again, my general equation that we just listed above looks like this. So I can see that the a value is -3. Now the c is a little bit tricky because notice in my equation, it's 1 over c. So 3 over 2 must be 1 over c. C is the reciprocal of 1 over c, right? So the just c should be the reciprocal of 3 over 2. So it's going to be 2/3. Everybody's okay there? And then our k value is our thing at the end, which is just 4. everybody feel okay with how I pulled those values? Now that I've identified my A, C, and K, I can use my equations up above to find my amplitude, my midline, and my period. So I know that the amplitude is the absolute value of A. So the amplitude is just the absolute value of -3. Well, that's just 3. The midline is y equals k. Well, my k is 4, so my midline is y equals 4. Important to remember, the midline is an equation for a line. It always starts y equals. The midline isn't just 4. It's the equation y equals 4. And then our period is 2 pi times c, or times, 2 pi times the absolute value of c. Well, the absolute value of 2/3 is just 2/3, and 2 pi times 2/3 is just multiplying fractions. So I get 4 pi over 3. Does that feel okay there? Pretty simple, right? We're just pulling the coefficients from the equation or from the function and then plugging each of those into the equation for amplitude, midline, and period. So I have another example, but like whoop-de-dee-doo, it's doing the same thing, right?
You go back to the
What we're going to do next is we're going to look at how I go from an equation, or I'm sorry, go from the function, the graph, back to the equation. Okay? So I'm going to go back to those two graphs that we started with and show you how I can use what I saw in the graph to write the equation for the function. So here we saw that the midline was y equals 1, the amplitude was 3, and the period was pi. Right? We just did this a moment ago. We looked at the picture. So since the midline is y equals 1, and the equation for that is y equals k, that just tells me that k is 1. Easy peasy, right? Since the amplitude is 3, and I know to calculate the amplitude, that's the absolute value of A. So the absolute value of A is 3. So A should be plus or minus 3. I'll tell you in a minute how we conclude that it's positive 3, but I'm not ready to do that quite yet. We said the period was pi, and then we know the period is 2 pi times the absolute value of C. So we have the equation pi equals 2 pi times the absolute value of C. To solve that for C, we divide both sides by 2 pi to get 1/2 equals the absolute value of C, or C is plus or minus 1/2. The way that I'm going to show you to do this, and I think the simplest way to do all these problems, will always be to choose C to be positive. Every time, every one of these problems we do, just choose C to be positive. Take my word for it. It's going to make all of the decisions there afterwards that much simpler if we just assume C will always be positive. Now, we have two things left to figure out, right? We have to figure out, okay, should this be sine or cosine? And then should this A be positive or negative? To decide this, what I'm going to do is I'm going to go back to my graph and look at what's going on when x is 0. Okay? So when x is 0, my graph is crossing the midline. You guys see that? That tells me to choose sine instead of cosine. If at x equals 0, the graph was at an extrema, a max or a min, I would use cosine. Okay? So far, so good. Now I have to show you how I choose between positive A or negative A. So in the case of The graph crosses x equals 0 at a midline. I look at the next extrema after that, which is this. Since that's a maximum, A is positive. If the next extrema afterward was at a minimum, A would be negative. If this was a cosine graph, where at x equals 0, we're at a maximum, A would be positive. If it was at a minimum, A would be negative. That's if we're doing a cosine. Does that feel okay? So just some rules that we have to remember on how to do this. So that's how I decided to use sine and positive 3, and then I just plugged everything in. Notice we haven't talked about what the h is. For this assignment, for the Delta Math assignment, the h will always be 0. Okay? What we'll do today will include some problems where h doesn't have to be 0, and we'll look at how to do that. So let's look at this one here. So midline was y equals 1. That tells me the k is 1. Amplitude was 2. That tells me a is plus or minus 2. The period was 4 pi. That tells me c was plus or minus 2, but I always assume c is 2. Everybody's okay there? To figure out whether I want sine or cosine, I go back and I look at x equals 0. At x equals 0, the graph is crossing the midline, so I know I'm going to write a sine equation here. Everybody's good with that? Because the next extrema after is a minimum, I know the a value I'm going to choose is the negative. So I wrote y equals negative 2 sine 1 over 2x plus 1. Is everybody okay? So again, all I'm doing once I figure out my A, C, and K is plugging them into the appropriate equation, whether it's sine or cosine, depending on what I saw in the picture. That's what we would have talked about on Friday. If you want to watch that again, where stuff comes in real time, that video is posted and dated for Friday. The Delta Math that I assigned as part of that will be due this Sunday. So if you haven't done that yet, that's part of this coming Sunday's problem set. Is everybody okay so far? Now this was not terribly complicated, right? So the Delta Math should feel similarly easy. Today we're going to look at, well, what happens, Mr. Kulik, if I do have an h that isn't 0, right? So let's do this one. This problem we'll do together in real time. So this one can be done the same way as yesterday's, or on Fridays, excuse me. So take a look at this. Can anyone tell me where the midline is?
Yeah.
Well, look closely, because this is 0 right here. Yeah, so it looks like -1, right? So I know that it gets, I put the grid lines in there, but it gets kind of busy, right? Okay. Now, what's the amplitude? Who can tell me what the amplitude's going to be?
2.
2. Very good. So it's just like this vertical distance, right? We start at -1, and it ends at +1. So that's going to be 2. Still feel pretty good? Okay. I'm going to look for the period next. So I'm going to say, I'm going to identify one cycle on my graph. So like that's one cycle. Doesn't matter where you started and where you started at, as long as you have one cycle. I like starting here because we're at x equals 0. What x value does my cycle end at?
4.
Well, that's a pi. I know it's maybe hard to see from back there. Just a pi. So how far is that from 0 to pi? Just pi, right? So far, so good? All right. Y equals 1 tells me the value for A, C, H, or K. K, and what is that value for K? 1. Okay. The amplitude tells me the value for A, C, or H. A, and that tells me that the absolute value of A is 2, so A is going to be plus or minus 2. Well, we don't know yet. Let's you know, but like, let's talk through how I determine that, but I'm not going to do that quite this second. We will get there. And the period, that tells me C or H. C, right? And that tells me that the period, pi, is equal to 2 pi, absolute value C, right? So what does the absolute value of C have to equal? So you're dividing both sides by pi over 2, or I'm sorry, by 2 pi, right? So what do you get? Pi divided by 2 pi? 1/2. So C will be plus or minus 1/2. But what do we always do with C's? Always take the positive. So everybody, so far, so good. Okay. Now what I want to do is decide whether I want a sine or cosine function. So I go and I look at what is the graph doing at x equals 0. Okay. Is it a maximum, minimum, or midline? That's a minimum, right? That tells me sine or cosine. Cosine. And because it's a minimum, that tells me the A should be negative. That's everything I now need, right? So y equals, and again, that general formula, I'll write it this way. I'll just write trig there because that trig could be sine or cosine, right? So that's going to be -2 because we said the A was negative. We said cosine because at x equals 0, we're at a minimum. 1 over c is just the reciprocal for c, so that's 2. H was not needed, so that's 0 plus k, right? But Mr. Kulik, on Friday you said any of these wavy shaped graphs could be a sine or a cosine function, right? So couldn't I have written this as a sine function? Yes, I still can. Let's show you how we do that. So remember when we did the graph of, do I have this on? I thought I did. Oh, I guess not. That's fine, whatever. Okay, so what I do to do this as a sine function, I'm going to pick some midline point from my graph. It doesn't matter which one, although the one you pick will affect your answer, but you can pick any one of them. So any point where the graph crosses the midline would be a good one to choose. Let's say, for example, we picked this one right here. So far, so good. So what I need from that is the coordinate. So if I look, I see I have 1, 2, 3, 4 tick marks to go from 0 to pi, right? That means every tick mark is 1/4 of pi. So that first point is at pi over 4. And since it's on the midline, I know negative 1. I'm sorry, positive 1. Wait a minute. Guys, that was y equals negative 1 for the midline. Oops-a-daisies. Were you trying to tell me that earlier and I just ignored you? If you saw it earlier, shame on you for not yelling it. Okay. So got that all fixed. Everybody's okay? So this is if I'm going to do a sine, I need a midline point. That's the coordinate. The x-coordinate is going to be our h. And then to pick whether the a is positive or negative, what do I look at? The extrema after the midline point, which is a maximum, which tells us the a should be positive. So my other version, I could write y equals 2 sine of 1 over 1/2, or just the reciprocal of 1/2, x minus h, which is pi over 4, then plus k, so minus 1. Both of these two equations will give me the same picture. Just to verify or to prove that to you, I'm just going to open up this piece of graphing software here and show you that I get the same thing. So there's my cosine function. There's my sine function. Notice, what did you notice? It's the same picture for both, right? Nothing changed when I did it. So I'm positive I'm correct. Both these answers describe the same picture. Does everybody see that? Now, for the record, I've seen I can get at least 2 answers that are correct. How many correct answers could I write for cosine? Infinitely many, right? Because I could use any of the maximums or any of the minimums to do it. And how many different equations could I write for sine that could be correct? Infinitely many, because I could use any of the midline points to do this, right? So on your test or quiz or whatever, either I'll specify the points that you need to use to write the equation, or I'll give you credit for any correct equation. So it'll depend on the directions. It'll often be a graph like this, but I'll have points labeled on there for you so it's super clear what the points are. You don't have to read it from the graph. In that case, it'll probably say using the points given. All right, let's do another example. So one thing I want to point out right away is that x equals 0, we're not crossing at a midline point or a maximum or a minimum, are we? Go ahead. So this one, both the sine and cosine will have an h in it. In general, that's usually the case. All right, so let's look at our picture. Who can tell me what the midline is? Yeah, it looks like 3, doesn't it? Okay. How about the amplitude? Two. And then the period. So this is a little bit tougher, right? So I'm not going to start at x equals 0 because I don't have like a landmark point that I can tell really easily where that is again. So I'm just going to start at a maximum. Let's say this one. So one cycle will end at the next maximum. Everybody's okay with that? Now, what do you notice that's unfortunate about those maximums? They don't end at a grid line, right? Where does it look like relative to the two grid lines that it's between? What do you think that is? Looks like halfway to me. You guys buy that? So if I look, I count 1, 2, 3, 4 grid lines to go from 0 to pi. You guys see that? So each grid line is a fourth. So how much is half a grid line? An eighth. So this spot over here would be like negative pi over 8, comma 5. And this one over here, let's see, that's 2 eighths, 4 eighths, 6 eighths, 7 eighths. Is everybody okay there? How far did I go from negative 7 or negative 1/8 to positive 7/8? How much distance did I travel from negative 1/8 to positive 7/8? 8/8 or 1 unit. Everybody agree with that? So that means our period is pi, right? Because we went from negative 1 pi over 8 to positive 7 pi over 8. Now, Mr. Kulik, I've seen that period of pi before, right? That just happened over here. You guys see that? So I'm going to just shortcut to say that, okay, well, I know C is 1/2 then. Since it's the same work as before, I'm just going to steal my answer from the previous one. Does that feel okay? That's working smarter, not harder. You know what I mean? We know the A then is going to be plus or minus 2. And the amplitude is going to be, or the K is going to be 3. So far, so good. All right. So let's do for cosine. I need to pick a min or a max. Any min or max from the graph is fine. But you'd be crazy not to pick one of the two max that we've already identified the coordinate for. You guys agree with that? So let's say we pick this one. So what is the H got to be? Just the x coordinate. And is the A going to be positive or negative? Since that's a max, the A has to be positive. So when I plug everything in, I have y equals positive 2 times cosine of 1 over 1/2, or just 2, times x minus a negative pi over 8 plus 3. Does that feel okay with what I did there? To do sine, I need a midline point. So let's say I pick that one. Any midline point is fine, but I'm going to pick that one. Is that okay? So I need to identify the coordinate there. Well, that looks like just half a unit from 0, right? Well, we already said that was pi over 8. So that's my h. And because the next extrema after my midline point is a minimum, what does that tell me about the a? It's negative. So there's a sine answer and a cosine answer. Unless the directions specify, 1 is enough. And the choice of which one to give me, unless the directions specify, is up to you. Right? So the directions might ask you to give both, or to give just the cosine one, or just the sine one, or to just give any one, depending on the direction. You just give the version that it asks for, or the versions, if it asks for 2 versions. So far, so good? Do we feel okay with this? Not too bad, right? Mostly we're just using our eyes, nothing complicated like algebraic has happened here, right? We're just learning how to read the graph and figure out, like, what do I do with what I see? Yes, sir.
May I please use the restroom?
Sure. Let's do. What did I have this one in here for? Oh, hi. Thank you. Well, we got Naya, Cameron, and this must be Valen. This is Maria.
Yeah.
That's you too?
Yeah.
You have enough names.
Yeah. That's my first name.
That's okay. I'm not just teasing. You guys want you to come grab your passes? I'll just sit over here. When Cameron gets back from the bathroom, someone who sits near him, can you help me tell him to take his pass?
Okay.
Okay. Should we do another one of these examples? All right. So, start with the midline. Who can tell me the midline? -1. What does that midline tell me? Good. Or, well, -1, right? Good. So the next thing I was going to ask for is the amplitude. Well, we know the amplitude is 2, but the A could be plus or minus 2, right? Because the A amplitude is the absolute value of A. Yep. So far, so good? Okay. Who can tell me the period? That looks like 1 cycle to me, right? Good. So the C is?
So I guess 5 then? Or, yeah, because you gotta get all that stuff out.
Yeah, there you go. And we always pick it to be positive, right? So we know that right away. All right. So if this is a cosine equation, what can we say? Which extrema would we pick? Dude, I picked this one, right? What's the advantage of picking that one?
As long as
It's the x value is 0, right? Yeah. So that's a minimum, so that tells me the a is negative. So my cosine answer will just be y equals, well, the h is 0. Maybe I'll write that down. We set it. -2 cosine 1/1/2, so the reciprocal, that's just 2 minus 0 plus k. What point would I want to pick for a sine function? What's the point that I could pick? You want to pick that one? It's good as any, right? So if I look at that, that is at 1 tick mark. I count 1, 2, 3, 4 tick marks that make up pi. So that's pi over 4. So that tells me the h is pi over 4. Now, is the a positive or negative? Positive, because if I look at the next extrema, it's a maximum. How you guys feeling on these? It's all right? Take some practice to get the hang of, but it's nothing like tremendously complicated, right? The algebra is not yucky. You basically just are using, like, you just have to kind of think about what's going on, but the algebra is not too yucky. What I want to do next is I want to say, okay, instead of giving you a graph, what if I just give you a description of what's going on? So let's see how to do some of that, okay? So in our first example, it says construct a sinusoid with amplitude of 4, period of 3 pi, and passes through the point 3, 1. So sinusoid tells me I could use sine or cosine, so I have a free to choose which kind of equation I want to write. What's the amplitude of 4 going to tell me?
that's that you go up and down for the midline, has to have like 4 above, 4 below.
Good. But in terms of writing the equation, which is what I want to do, it tells me the a is plus or minus 4. You're correct on that, but the goal is to write the equation, right? If the period is 3 pi, what does that tell me? It tells me 3 pi equals 2 pi times the absolute value of c, right? So if I divide both sides by 2 pi, I get the absolute value of c is 3 over 2. So c is plus or minus 3 over 2, but we always pick the positive. So we have that. So far, so good. Now, if I look at this point, do we know anything about that point other than its location? Do you know if it's a maximum, if it's a minimum, if it's a midline point? Do we know anything about it? No. Guess what? That gives us the freedom to choose that midline point or that point to occur anywhere on our function. Okay, it doesn't tell us where it has to be. I can pick the kind of point I want that to be. To make your life as easy as possible, we're going to pick that to be a midline point. What that tells me is it tells me that I'm going to use sine. It tells me the h is 3, and it tells me the k is 1. And I'm done. I now have everything I need. And you're saying, wait a minute, Mr. Kulik. Wait a minute. Hold on. Because I still see a plus or minus a. You haven't decided whether that's positive or negative. Guess what? Doesn't matter. Either answer is going to be correct, and I'll show you why in just a moment. So again, I wrote y equals a times sine of 1 over c. So I did the reciprocal of c. And then x minus h plus k. So just to kind of show you guys. So here's the point 3, 1. So we have y equals 4 sine of 2/3 x minus 3 plus 1. Notice that graph goes right through that point 3, 1. Or if I use negative, different graph, but guess what? Still goes through 3, 1, still has the same amplitude, still has the same period. So it's still correct. It meets all the specifications, even though it's technically a different graph. It's fine. Is that okay? Yes?
Do you always divide the period by 2 pi?
To find C?
Yeah.
Yes.
All right.
So if we look back to yesterday, one of those equations I gave you is that the period is 2 pi times the absolute value of C. That's always the case. So that's always how we'll backtrack and find C. All right, one more example. Here we have construct a sinusoid that has a minimum value at 5, 10 and a maximum value at 15, 32. Well, I'm going to start by just kind of sketching a little bit of a picture about what's going on, because here's not a lot of information, right? Just giving me 2 points and nothing else about what's going on. So it says I have a minimum at 5, 10, and then we have a maximum at 15. Oh, the next maximum even, it tells me specifically. Is everybody okay there? So we know like the midline is going to look like this, right? Yes, sir. Sure. So we know that midline has to be halfway in between the minimum and maximum, right? That's what we just drew. So to do that, I can just take the average of the maximum y coordinate and the minimum y coordinate. So I get that k is 21. Is everybody okay with that? Now that formula I wrote down, y max plus y min over 2, you can use anytime you have a min and a max like this. That'll work. Now if I look at this distance, what is this distance that I just drew there in green? Well, that's twice the amplitude, right? That's 2 amplitudes. So if I calculate that distance and divide by 2, that'll give me an amplitude, right? So that's going to be the y max minus the y min, because we're doing distance. Divide by 2 will give me 1 amplitude. God bless you. So the A is going to be plus or minus 11. So far, so good. Let's look at this picture here. So how much of a cycle does it look like this part in yellow that I've highlighted is? How much of a cycle does that appear to be? Looks like half a cycle, right? So I know then that, get a color here, that this is going to be half a period, right? So I can say 1/2 period is equal to the x max, and its distance, so I'll be subtracting, x min, but I'm going to stick a absolute value around that because I don't know in the future what if they gave me the maximum first and the minimum second. If I subtract those, then I'm going to get a negative number. I'm still going to want, if I just stick an absolute value around that, this formula then works no matter the order of what I got. So that's why that's there. So what that tells me then is if I multiply both sides by 2, the period will be 2 times the absolute value of x max minus x min. So if I start plugging things in, the period is 2 pi times the absolute value of c. X max is 15. X min is 5. So I have 5, or 15 minus 5 is 10, and then times 2 is 20. So if I divide that by 2 pi, and I can reduce to get, 10 over pi. And we'll always choose C to be positive. So we have that. So far, so good. So we have K, we have A, we have C. What do we still need? Well, it's H. Or H. Yeah. So, to find that H, I'm going to use one of these 2 points. Since these points are both extrema, min and max, which function am I going to use? Cosine or sine? Cosine goes with mins and maxes. Sine goes with either a free point, like the last one, or a midline point. Okay? So we're going to use cosine. Now, which one do you want to use? Let's just say we pick this one because I saw this one first. What type of point is that? It's a minimum. What does that tell you? Other than we're using cosine? It also tells us about the sign for A. A will be negative. Now we have everything we need. So y equals negative 11 cosine of the reciprocal of c, so pi over 10, x minus h. Oh, the h is that 5. Forgot to say that. And then plus k. And again, just to illustrate to you that this is going to give us the same answer, or going to be giving us a correct answer. So here's 510, 1532. And then y equals negative 11 cosine of pi over 10, x minus 5 plus 21. Notice it goes through both those 2 points. That's all it needs to do. If I had chosen the other point to use, if I'd used the maximum instead, a would be positive and h would be 15. What do you notice when I changed it? I still got the exact same graph, right? Both answers are correct. They'll be accepted either way. No preference given. Do we feel good on that? All right. That's the gist of what we've done up to this point. So if you haven't done the delta math, I would suggest starting on that today. Because if you can't find like the midlines and amplitudes and periods and do those sort of little simple calculations, getting the entire equation out from the graph is a much harder proposition. So I'd like you to practice that first. After that, you should look at worksheet 5, which is going from graph to equation. In worksheet 5, I give you points labeled on the graph and ask you to write your answer with sine and then also with cosine. And I have 2 graphs for you to do that with. That's all of worksheet 5.
So it's just 1 through 3?
It's 4 because you have to do it for sine and cosine. And then worksheet 4 are descriptions, just like we saw in the most recent 2 examples. On worksheet 4, though, I do not want you to do number 3. Because it's asking you to do it the hard way, and we don't have to worry about it. It's saying, here's a here's a free point and do this for cosine. I don't want you to do that. That's the hard version of that problem. You'd never want to choose to do it that way. Let's not worry about practicing it that way. Questions so far for me about what's due. So worksheets 4 and 5 will be part of Sunday's problem set, along with the delta math if you haven't started on that or finished that. My apologies that the sub didn't communicate those things effectively to you. I'm going to give you the rest of the time in class today to get started. My suggestion for you, get something out, tablet, crank away at the delta math if you haven't done that yet. If you've already finished that and you want to start on worksheets, I recommend starting with worksheet 5 before worksheet 4, because I think having the entire graph is a little bit easier than just some information about the graph. And that's the plan. Cool beans?